So the ideal emulsifying agents should have some properties I have told you. Next, what should be the mode of action of an emulsifying agents? Concentrate at the and are absorbed uh, onto the oil water interface to provide protective barrier around the droplet, and they stabilize the emulsion by reducing the interfacial tension of the system, uh, imparting a charge on droplet surface, reducing the physical contact between droplets and decreasing the potential for collisions. Okay, so the emulsifying agents, there are classifications of these emulsifying agents. There are five types: natural emulsifying agents, semi-synthetic polysaccharides emulsifying agents, synthetic emulsifying agents, inorganic emulsifying agents, and the alcohols. From natural, there comes from two sources: vegetable sources and animal sources. From vegetable sources, the examples should be gum acacia, tragacanth, agar, pectin, starch, Irish moss, and from animal sources, wool fat, egg yolk, gelatin. The semi-synthetic polysaccharides emulsifying agents, here the examples are methyl cellulose, sodium carboxymethyl cellulose, etc. The synthetic emulsifying agents are three types: anionic, cationic, and non-ionic. And inorganic are examples of inorganic emulsifying agents are milk of magnesia, magnesium oxide, magnesium trisilicate, magnesium aluminum silicate, bentonite, etc. And the alcohol type emulsifying agents are carboxyls, cholesterols, lecithins. Here, here we can see that surfactants are basically emulsifying agents are surfactants which have two parts: head part and tail part. I have told you that polar head and non-polar tail. Polar head should be the hydro hydrophilic property, and uh, tail part have the lipophilic or hydrophobic property. So move to liquid-liquid interface, reduce the surface and interfacial tension of that system. See, hydrophilic and lipophilic portion. Hydrophilic part, amino hydroxyl carboxyl, and lipophilic part, alkyl chain. So surfactants are these categories. I've told you the natural part. There comes from the vegetative sources and animal sources also. Okay. From natural emulsifying agents, animal origin, wool fat, egg yolk, gelatin, cholesterol, pectin, Cronus, and from plant origin, acacia, tragacanth, agar, pectin, starch, iris moss, etc. Here, the synthetic emulsifying agents. See, the synthetic emulsifying agents, which are three types. First one is anionic, cationic, and non-ionic. Anionic, which pH are greater than 8. Examples are sodium or potassium oleate, triethylamine ethanolamine stearate, sodium lauryl sulfate (SLS). Then second one is cationic, which pH varies from 3 to 7. Here greater than for anionic, pH should be greater than 8, and here pH should be ranging between 3 to 7. Examples are benzalkonium chloride, benzothonium chloride, quaternary ammonium salts, etc. And examples from the non-ionic part, where pH varies to 3 to 10, uh, polyglycol, fatty acid esters, lecithins, sorbitan esters, spans, that means polyoxyethylene derivatives of sorbitan esters, twins. So sorbitan esters are two types, spans also twins, glyceryl esters, Cationic and anionic surfactants are generally limited to use in topical O by W emulsions, or that means oil in water type emulsions. There are some higher molecular weight alcohols. I've told you before that they are carboxyls, cholesterols, and the lecithins. Steadyl alcohol, cetyl alcohol, glycyl, monostearate, etc. And the inorganic part is the finely divided solids. Examples are bentonite, magnesium hydroxide, aluminum hydroxide, etc. Okay. So basically, emulsifying agents may be classified as follows. First one should be the natural emulsifying agents from vegetable sources. These are carbohydrates, which includes gums and mucilaginous substances. They are anionic in nature. Okay, so vegetable natural emulsifying agents for vegetable sources are anionic in nature and produce O by W, that means oil in water type emulsions. The emulsions prepared from these emulsifying agents need suitable preservative to preserve them because the carbohydrates are act as a medium for bacterial growth. Remember, where we are using these vegetable sources or the natural emulsifying agents, um, we have to remember that use of preservatives is so much important because carbohydrates acts as a medium for bacterial growth. Okay, the following are some emulsifying agents belonging to this class, like acacia. Acacia is considered to be the best emulsifying agent for extemporaneous preparation for emulsion for internal use. Okay, emulsions prepared with gum acacia are attractive in appearance and quite palatable and relatively stable over a wide range of pH 2 to 10. The emulsion prepared with gum acacia usually have low viscosity, so therefore creaming take place quite rapidly. Okay, these have advantages and disadvantages also. In order to make a stable emulsion, the other emulsifying agents such as tragacanth, agar, pectin are also used with gum acacia. I have told you that emulsifying agents we have to use very properly. Uh, One emulsifying agents cannot produce a stable emulsion. For that reason, you used to use two or more than two emulsifying agents side by side. So along with the gum acacia, here we also use tragacanth, agar, pectin, which increases the viscosity of dispersion medium, so that creaming does not take place. Gum acacia is used in the following ratio for preparing emulsion from various types of oils, like fixed oil is to gum. The ratio should be 4 is to 1. And for volatile oil, volatile oil, the oil and gum ratio should be 2 is to 1. And for mineral oil, the oil and gum ratio should be 3 is to 1. So gum acacia complete, then comes to tragacanth. Tragacanth alone is rarely used as an emulsifying agent because it produces a very coarse and thick emulsion. The appearance and stability of the emulsion can be improved by passing the emulsion through a homogenizer. Stable emulsion can also be produced if tragacanth is used along with gum acacia as an emulsifying agent.